So I'm Shay, and I got my start with programming in 3 ways. And so the first of which was Minecraft. And so Minecraft is this game that I played back when I was a freshman. So I'd spend nights up late, playing with friends online, burning down each other's houses in the game, and not doing homework. And one of the things that interested me about Minecraft was that it was created by these guys, this really small company, who were all programmers. And so I became interested in programming, and specifically how to modify the game. And so the term mod means that the way that you're able to change the way that the game works, so either affect kind of the physics of the game or actually add different things to the game. And so I was interested in doing this myself. And so I began searching for it right about there, if you look at this Google Trends thing of the search for how to mod Minecraft. But the tough part was that I was looking like this, and I was coming to the tough realization that coding isn't easy. I'm having trouble with this. I'm going to stand right there. That coding isn't easy. My second interaction with programming was through Rootpick, and you might be asking yourself, what is a Rootpick? And so this is a Rootpick, and so he was in my freshman biology class, and he actually goes to CHS now, is in the IB program, and so I still see him from time to time. But what I would do is I'd walk into my biology class a couple minutes before class would start, and I'd see him working on his computer on something, and so I'd be like, what are you doing? Like, class hasn't started yet. And he explained to me that he was actually teaching himself how to code and was making his own game. And so that totally struck me because Rufik, who was 14 or 15 at the time, was teaching himself how to create a game and doing it all by himself, which was something that I thought you'd have to be in college or an adult to do. And so that kind of taught me is that anyone can code. And so my final interaction with programming before my capstone was the calculator. And so this is kind of a funny story. I'll tell it from the perspective of my now friend, Sabrina Sadler. So basically you came running in and you sat down right next to me and you shoved your calculator in my face. You said, you gotta look at this. It's super, super cool. And I didn't know what it was, and it wasn't that cool, and it was really kind of shocking. And so what I had done, is I created a program on my calculator that I wanted to show everybody. And so I actually created a version here on my computer that I can do with you guys right now. So do I have a volunteer from the audience? Anybody?
Sure.
Yeah, all right. So what's the month of your birth, like in numbers?
6.
Okay. What's the day of your birth?
21.
21. And what's today's month?
Today's is the 4th.
The 4th, and the day?
The 16th.
16th. So it is not your birthday. And so that was the program that I made, and it was really pretty lame, not that cool, and maybe the practicality wasn't there, but it was something that I had created, and it introduced me to the way that programming worked. And so when it came time to decide what my capstone would be on, I kind of thought back to all these different things that I worked on, and decided I wanted to make a game. And so I didn't know what that meant at the time, but the journey that's taken me on is really pretty interesting. So the first part of making this game was doing research. And so I did my research in 3 different ways, the first of which was taking an online crash course. And so this Code Academy is one of many websites available on the internet which puts you through an introductory course into programming. And so it's all kept on this one website, and it teaches you how to code, and it even gives you an area to code for yourself, and it grades your code. So it's pretty interesting. So the language that I learned here was JavaScript, which is not the language that I ended up using in my final product, but it gave me an introduction into the way that the logic of programming works and how code operates, and the syntax that it works in. My second was taking a Northlake College online class, and so this was just kind of an example of how difficult it was to deal with a professor through an online course. Is that especially being at New Tech and being taught to go seek out knowledge, it was tough dealing with a professor who was not used to having students ask a lot of questions, and so he became frustrated because I was constantly asking him how to work on my code. And the last thing was the internet. And so the internet was a great resource because when building my code and when actually writing it, you ran across a lot of different stuff that you'd have problems with as you were doing it. And you'd have to, and it would kind of baffle you at first, but using the internet, you were able to find the different fixes that people had come up with in order to fix your code. And so using all 3 of these, I went into actually creating my code. And so I broke this down into 4 stages, which were planning, writing, refining, and debugging, and then finally testing. And so the first one, planning. When you're writing a program, you have to know what you want it to create at the beginning in order to kind of structurize what you're going to be creating. And so for my game, I want it to be, first of all, text-based. I want it to be a turn-based fighting game. So if you guys are familiar, like with Pokemon, I doubt you are, but like a card game where like kind of each player takes their own turn. And the last was opponent artificial intelligence, meaning like the player, the computer that you're playing against is hard enough to where you don't win every time. So that led me into the writing, and so in writing you had to become familiar with a lot of different terms that you guys probably aren't familiar with, and it ends up looking a lot like this, which is totally tough to read if you're not familiar with it is, because I mean programming is another language. And there are multiple languages that programming and coding has. There's C++, Objective-C, JavaScript, HTML. And all that doesn't really mean that much, but the thing to know is that you have to know, in order to create what you want to know, you got to know the right thing to tell the computer to do it. So, for instance, if we wanted the computer to say, hey, how are you? The way that we do that within C++, the language that I chose to write it in, is count, meaning like output, and then you point to the outside of the code and say, hey, how are you? And then that /n means that it ends the line, ends the quote, and then a semicolon. So it kind of operates like a sentence. So this being like the command, like I want you to have an output. This telling the computer what you want to output, and then finally that semicolon acts like a period in the sentence. And so you really got to become comfortable with doing this because there's a lot of tricky code and different ways that you have to different things you have to tell the computer in order to get the code to work efficiently. Going into refining, one of the biggest ways that I did that was through compression. And so the way that compression works is it takes something that usually would take a lot of lines of code to work, and you're able to put into a smaller space. So for this demonstration, we'll think about if we want to make a sandwich. So I wrote some code talking about if we want to make a sandwich. So first of all, ask what kind of sandwich would you like? And then you say what kind of sandwich you like. And so if the sandwich type is a peanut butter and jelly sandwich, then you go through all these steps in order to create the peanut butter and jelly sandwich. So it's gathering the supplies, putting down the bread, spreading the peanut butter, spreading the jelly, placing the bread on top, and cutting it in half. And so that's pretty lengthy just for one sandwich, but it doubles whenever you try to make two of them, to where it takes up like a crazy amount of lines. And so the way that you're able to get rid of all of that is by using functions, and one of the ways that you're able to compress. And so you can shorten all that into just this, where it's a statement. You want to make a sandwich, and what kind? PB and J. And so you're able to compress all that into a small space by saying, this is what I want make a sandwich to be if I want to make a peanut butter and jelly sandwich. And so you're able to shorten whatever, those 20 lines into just these two. The final thing was testing. And so the one thing that testing inevitably would lead to is finding more bugs and ways to improve it. So you'd show your friend, you'd show your parent, or a facilitator, and then they would often find a way to break the code and to make it to where it wouldn't function anymore. So you would have to go back into your code and look at the ways to kind of fail-proof it in order to avoid those. And so all these different stages went into me creating the game. And so the game is called Ninja Warrior, and so we'll play it for a little bit right now. So do I have an audience member who would like to volunteer? Megan? Okay, so what's your name? So I know your name, Megan. So what's your enemy's name?
Doug.
Doug. It's funny, I presented this so many times, and 9 times out of 10, they'll say Doug is the enemy. That's just how it is. So instruction time, press enter to continue. You're a master ninja named Megan, and you're fighting against the evil ninja Doug. In an effort to defeat them, you have 3 attacks. Your first attack hits your enemy 100% of the time and deals 5 damage. Your second attack hits your enemy 50% of the time and deals 10 damage. And your third attack hits your enemy 20% of the time and deals 20 damage. Your enemy has the same attacks, and you each start with 100 life points. If you need to see these instructions again, say help during battle. So good luck, Ninja Megan. Press enter to begin. So it starts off by saying how much life you each have, and then it asks you for which attack will you use. So let's go for the sure one, so 1. And so we hit Doug and deal 5 damage, but Doug chose some kind of attack and missed. But we can go ahead and try 2. So we missed, but they did attack 1 and dealt 5 damage. And so we can keep playing this. We'll just do 3. You want to do 3?
Oh, yes.
So we did 30 damage. We can keep doing that. I'll skip to the end just for the sake of this. And so we get him. So we won the game. And so it asks you, would you like to play again? And we'll go ahead and say no. And it tracks how many wins and losses you have. So if you want to play again, you can keep playing Doug, and then it'll track how many wins and how many losses you had. So that's the game, and it was kind of interesting to create. But looking back at this whole process and this whole Capstone experience, one thing really kind of comes forth as the big reflection, and that is that I don't like programming. Like, it's something that like I was interested in, but like I'm totally not about the programming. But I think that's a good thing because first of all, it avoids me pursuing it in college. It's something that I know I gave it a shot, but it would not fulfill me in a career the way that I would want it to. I got to explore an interest of mine that I had for a while, and it gained appreciation for programming and new tech. And so I'd like to focus on that last part a little bit, the appreciation for new tech, because I think there's a relationship between both of these. So the first kind of centers around this idea of you can't fake code, is that when we look back at the code for the game, the only part that you're dealing with when you're actually playing the game are these 4 or 3 lines right there, is that those are just constantly going over and over again. But before you could even just write that, you have to have so much more backing it up. So if we think about this as like a final presentation, like this is just the flashy part, but you have to have so much substance before in order for this to really work. So you can't fake a presentation, or rather you can't fake a good presentation. They both require this necessity for substance. And then debugging. And so if we think about debugging with this relationship to testing, I kind of went over this before, is that debugging leads to testing, which inevitably leads back to debugging. So it kind of creates this cycle. And so if we think about debugging as like a way of life, it is always looking at yourself and seeing the ways that you can improve, and checking on the different ways that you can refine yourself. And if you think about the things that we do in New Tech, this process of critical friends, and allowing others to look at your life and kind of refine the way that you're holding yourself, and allowing others to be that person for you. So looking towards the future, I'll be attending Clemson University in South Carolina. I don't know what I'm going to be majoring in, but it's not going to be programming. But I want to make sure that I'm always remembering New Tech High at Capel, because I feel like a lot of what I am today and the person I've become is because of the formative experience I've had at New Tech. And the relationships that I built there and the experiences that I've had have really kind of molded me into the person I am today. And one thing that I'd like to close on is, if New Tech High at Capel has taught me only one thing, it's to be constantly debugging yourself and refining your moral code. Thank you.
Okay, and we're going to move on into questions.
Thank you, Doug.
So did you break into the CISD code? I saw that down
I
there.
saw that too.
Yeah.
No, you can't do it for some reason.
You can't imagine that.
So glad.
I put that in there to
He
hopefully
didn't
cover
try
it.
either.
No, I did not try. I don't know how
Oh,
you...
darn.
I will say that the code that I created is like leagues more simple than the stuff that you're holding like in your hand. Is that it's a very simplified, but it did give me an introduction into how all this stuff kind of works and the logic that it has.
And then you said with coding, you said you started with JavaScript. Is there a reason why you did C++ versus JavaScript or HTML? Is there a reason why you went that route? I mean, even just basic, good old, I'm dating myself, I'm sorry, basic code back in the Apple II era of computers.
So the reason that I chose JavaScript was mainly, I did the research on that website. It was called Code Academy, and that was just one of the languages that was available. And a lot of these languages have very similar syntactical stuff in the way that they the way that they kind of look, even though certain words might be switched. So if you think about kind of going from Spanish to English, is that even though the words are different, sometimes that the order of the words is the same a lot. And so that's kind of the approach that I had for JavaScript, is that they didn't have C++ available on a lot of websites, but JavaScript was very readily available, mainly because it's meant to be written for websites, is that it's a web-based language. And so I did that to kind of teach myself more of the syntax and stuff and become more familiar with that. But then to do my game, because I was operating on a Mac, but I wanted it to be available also on PC, is that C++ is able to be run on both, and it's able to be run just on the computer versus having to be operated on some kind of website. It's like a native, I'm not sure if that makes sense, to where it's just operating on the computer versus on the interweb. Do you have any more questions?
Doug, what was the biggest challenge throughout working through your capstone?
Probably the biggest challenge was, sticking, or I guess would be conceptualizing how to even approach something like that. Because even though, again, it wasn't that complex, is that it was way more complex than anything I've had to do. So having to think like, okay, so I want to create a game, and there has to be like an opponent that fights me, and so kind of like doing some research into how I could get that to work. And so the way that I actually dealt with like the opponent with the artificial intelligence there was that it all operated on random numbers, and so it would generate a random number that would decide which attack it had, and then it would generate another random number which would decide whether or not the attack hit. And so kind of conceptualizing how each of the different pieces would work, and then how they would all work together. So like if I could go back real quick to the to this part, which was, I mean, again, this is the only part that's working. That this is just do while just means that it's constantly looping, and so it does it over and over again until living, which is the integer I chose to denote whether or not you were living, is equal to 0. So basically, this would be the enemy's health is affected by your attack, and then this is the user's health is affected by the enemy's attack. And so this is where you deal damage, this is where they deal damage, and then this checks whether or not both of you still have above 0. And so this is like the only part of the game that's really operating, but you have to have each of these things need to be defined way before it to make sure that you understand it.
That concludes the time.
You can keep it.
Outside of time, just quickly, so that's not all of the code for your game, correct?
No, it's
How-
not.
Oh, good.
Yeah, so how much code went into that game? 'Cause
So basically, it started at about 1,000 lines of code, but then using that compression, I talked about this stuff that's constantly used over and over again. I was able to shorten it. It's just a tiny bit over 200 lines.
So basically, right about a full page.
Yeah.
Gotcha.
Do you have any more questions?
Several pages. All right.
No. Thank you guys so much.
Thank you, Doug.
Thank you.